Welcome to this talk on TILT, a GDPR-aligned transparency information language and toolkit for practical privacy engineering. My name is Elias Grünewald. I'm your presenting author, but this is joint work of Frank Pallas and me. We are both members of the Information Systems Engineering Group at TU Berlin. So if we are talking about privacy or transparency in particular, everybody talks about privacy policies, written privacy policies. As the New York Times put it, they are an incomprehensible disaster. Everyone knows that if you read such a privacy policy, you don't fully understand it, and it doesn't really help you understand how services treat your data. So there are new approaches, such as Apple's privacy labels. You can see them on the right, for example, that they inform you about contact information or location sharing or other identifiers that are data that is used to track you or linked to you. And we like to see such new approaches, but we think there is still a missing gap about how this is technically solved. So the foundation of our work is the EU General Data Protection Regulation, the one you all know. It lays out the general legal framework of data protection in Europe and beyond. But we are computer scientists. We want to get to know what is happening in the machine room, or what do developers have to do with the regulation. And so our motivation is to introduce a new standardized machine-readable format for transparency information in accordance with the EU GDPR. And we want to do it to the full extent required by law. In particular, we are referring to Articles 12 and 13 and 14 and maybe also 15 and 30. And we want to do it in a fully comprehensible and transparent form, as required by Article 5 and 12. So we want to enable that data subjects can get the exact information they need to know through adaptive or contextual interfaces or by preferences. So data controllers also need to process the information. It may be internally or externally, and they want to do it in a much more versatile and efficient way. So we need to provide a new technical measure for doing that. Let me introduce you the journey of this talk. So first, I'm going to elicitate the requirements we collected for our paper, and afterwards the legal foundations and what we call the expressiveness of our language. Then we are going to dive deep into the language design and its implementation. Afterwards, I present you the toolkit and future work. So transparency, and especially technical approaches to transparency, such as transparency enhancing technologies, are discussed for a long time. For example, you can see the Web Privacy with P3P paper by Laurie Craner of 2002, or newer approaches from industry, such as the Transparency and Consent Framework by EIB Europe. And there is also more recent work, such as privacy policy knowledge extraction. So you use AI to extract information from written privacy policies, as the paper on the right indicates, from 2016. But we collected a few requirements that we think have all been met by such tools. And those are the sufficient expressiveness to meet legal obligations. So with the new GDPR coming into force, there were many information obligations carried out that still many providers of different services do not meet. So we need a more and better approach for standardization to commonly use transparency information items. So the General Data Protection Regulation, for example, requires us to inform about third country transfers or automated decision making in use, or all the recipients of personal data that are involved in any processing activities. And for that, we want to enable a new language. And other requirements, for example, the inter-system communication is key to a new technology that is used in practice, because today's information systems are highly distributed and still very complex to understand. And so we want to have measures that are also able to communicate with these variety of systems. So we also want to have it domain-specific or application-specific extendable. So, for example, if you are not only thinking about transparency, but also consent, for example, such an approach or such a technical measure needs to be extensible and reusable. Of course, you don't want to implement anything twice, or if you implemented once a new technical measure to enhance transparency, you don't want to implement it for your second service as well. So implement reusable artifacts is really important. And last but not least, what is often overlooked is developer friendliness. So far, we see different approaches that are concerned with transparency or privacy related issues and that are mainly tackled by the law department, for example. But we also think that the computer science community, or especially developers who implement systems, should also be made responsible for their actions, but not also be made responsible, but also give them a tool to make it better and to make it more transparent. So the sufficient legal expressiveness is what we think the most important of these requirements. And that's why we had a deep look at the GDPR. Especially, you all know that there is Article 12. It's on the transparency and its modalities. So we made this table on the right, it's directly from our paper, where we collected all the references from GDPR with regards to transparency. For example, the controller or the data protection officer needs to be mentioned. And then we categorized them in the table as you can see it. But afterwards, we also checked what is in those written privacy policies in practice. So this is a long table. You can see it on the right with all the detailed information. What does it especially mean to mention the controller? For example, the company name or its address, and so on and so forth. And what information of that is really required or often seen in industry. So we made this detailed analysis and also double checked it with reality. So we saw more than 30 privacy policies and discussed them and compared them to each other and saw that we can have a fixed set of what we call building blocks of information that represent all the information required in such privacy policies. And then this is the key new step. We introduced a new formal language. We are computer scientists, so we want things to be deterministic in a way. And so we created a new formal language definition to represent all that transparency information in a formal language. So formal languages are good enough, but we also want to see that in practice. And that's why we implemented it using JSON schema. That means that we have a new JSON-based representation of all the transparency information required by the GDPR in a reusable format. You can see one example here. It's about the legal basis for any processing activities. And we, for example, created a pattern of how such a GDPR reference might be encoded, and what comes with it. Out of the box is a instant validation. On the left-hand side, you can see a valid legal basis because it follows the pattern defined above, but also an invalid legal basis would directly be recognized by our system. So we introduced this new machine-readable format, which then can be instantiated by different services or different companies. So what we call TILT is a uniformly represented transparency information format that is interoperable and meets all the requirements we listed before. Some details on the technical implementation. So as I already said, we used JSON schema for instant validation. And what is also important, JSON as a programming language agnostic format. So we don't want to create a one-shot solution, but rather anything that is interoperable with different programming languages. And so we also created several regular expressions and custom types for all the fields that GDPR requires from us. And technically, this is often solved in if then else or any of constructs for different legal cases. For example, the GDPR requires us to describe the involved logic if there is automated decision making in place, and our language can represent such cases. Or in terms of data retention, is it a temporal or a conditional information piece? So all the different fields are represented and also double checked by our validation mechanisms. But our paper is also called Toolkit for Practical Privacy Engineering, because we think it's not enough to only define a new language that is maybe capable of all the information, but to manage all the information, but we also want to see some use cases or application scenarios in practice. So we introduced the toolkit that, of course, relies on our formal language representation and validation, but also, for example, a document store, a version document store. So if we think about translating textual privacy policies into our new formal language representation, we can have them stored in such a database. But with this system comes a new component, for example, a transparency information API. That means you can program different services that interact with your policy. That is new. With written privacy policies, you can send them around via email. Well, that doesn't help anyone, but with a new transparency information API, you're able to react on what a company states and how it processes your data. So what is also thinkable of is a transparency information representation that is human readable. In literature, we discuss privacy icons or conversational AI that deals with transparency information or privacy information in general. But now we have this standardized new format that allows us to create several of these services that all are compatible to each other because they use the same representation format. And if we look at such a document store, this is one of our application scenarios described in the paper. You would first create such TIL documents. You can do this in different ways. We will dive into that in a second. And you can manage them in a possibly distributed store. So think about collaborating with your external data protection officer. He or she can then directly introduce new versions of your transparency information in that document store, or you can access, as told on the slide before, these documents via APIs. We also show that we can implement different types of APIs. For example, if you have a system that relies on REST, then it's fine. We are compatible to that. But if you are also interested in GraphQL, you can program a client that is also compatible to read that kind of information. And so we are really able to create new privacy agents. Such an API request might look like this. For example, you are interested in the controller's name and the protection officer as well. And for example, third country transfers, if that is relevant for your use case. And then you get an instant response about how the Green Company and Jane Wonder Woman are responsible for third country transfers to Spain. But that is not enough. We also implemented general purpose programming language bindings. So one is for Java. You just need to install our component and instantiate our classes, and you're directly able to modify them or to extend them by your needs. And we also did the same for Python, because we think both languages are used in practice in especially the web environment a lot, and you are able to perform analysis, for example, when you can iterate over all data categories that are disclosed to a certain recipient, or if you're interested in changing or modifying or displaying an address of a controller on your website, you might also be able to do this via our general language bindings. And new use cases come with that. So if we have machine readable and in a standardized formatted transparency information, we can also use that information to analyze data sharing networks. This is the architecture of what we call an analysis platform. So we store that information about transparency in a database, in a graph database, and then we can see, oh, green company shares your data with another yellow company, for example, and it does that for a specific reason. And so you can really dive into secondary sharing processes, and we think that's a whole new thing that is not possible with written privacy policies. Moreover, we are also introducing a human comprehensible interface. We prototyped a Chrome browser extension. So if we see that in practice, it would look like if the fact website would support it, such a window which you can open and then see, for example, that this website transfers your personal data to these 3 European countries, or that also automated decision making is in use. Of course, this is a prototype, and after more user studies and everything, we can improve that. But this is new ways of how to communicate transparently what a service does, and you get users that are much more informed than if they would spend hours and hours in reading incomprehensible privacy policies written in legalese language. So we also have to ask, why would an enterprise use such a language and toolkit? And well, we refer always to Article 25 of the GDPR. It says you need to take into account the state of the art and the cost of implementation of such a solution. And we introduced that new transparency information language and toolkit and proved that it's practical, and we lowered the cost of implementation by providing all these new components. And so we think privacy and also transparency by design is possible. And we also think that industry has to use comparable solutions or the toolkit itself, because GDPR requires to do so, but we are also aware that it's not that easy, and we also rather desire that our toolkit is improved by the community and adaptations happen, and then in a later stage it will be adopted in practice. That would be great. Future work includes the semi-automatic extraction of transparency information via natural language processing. You can see it in the right-hand figure, for example, that we want to transform the most important pieces of textual privacy policies in our representation format in a automatic or semi-automatic way, so that we can have a huge corpus of these formal language representation documents. And we also want to advance the interplay with other privacy languages, for example, consent-related or about accountable systems. There is a variety of languages that might be candidates for interoperable and different use cases. So we also want to incorporate advanced concepts from the GDPR, or maybe also from other legislative framework. But yeah, this is all for future work. We invite you to use our language because we open sourced it on GitHub. You can directly access it. There are more than 15 repositories with first experiments about natural language processing, for example, or our general language programming bindings, and you can use it, fork it, share it, study it. We are very happy to get in touch. If you have any suggestions for further improvement, we are very happy to receive an email or an issue on GitHub, and we will figure it out on how to improve our language. In this talk, we showed you that there is the regulation about data protection in Europe and beyond, and it's very complex, but there are also new ways on how to implement that in practice. And we think that is an important step in the right direction. And if you also think that, or if you disagree, then just write us an email or contact us on Twitter. We are available and very happy to share thoughts with you and your communities, and give us feedback or get in touch with us directly. Thank you very much for your attention, and have a very nice conference program. Bye bye.